Okay, here is another equilibrium example. So we're given a chemical reaction and we're given its equilibrium constant. And we're given the initial partial pressures and we're asked to calculate the equilibrium partial pressures. So the fact that the problem is talking about both the initial and the equilibrium conditions, this is probably a good candidate for an ice table. So before I even really think about the problem, I'm going to go ahead and set that up. All right, and let's put in what information we know, and then we can try to figure out how to proceed to get the information that we're asked for. So we have a KP, so we want to be working in atmospheres, and they gave us the initial partial pressures in atmospheres, so that's good. So the initial partial pressure of Br2 is 1.5 atmospheres. The Cl2 is 1.3, and nothing is mentioned about the initial partial pressure of the product, the bromine monochloride, so we can assume that that is 0. And we want to know the equilibrium partial pressure of BrCl. They don't give us any of the equilibrium partial pressures, but we do have the equilibrium constant. So actually, let me fix my equation here. I forgot the 2 in front of the BrCl, and let's go ahead and put in the change row. So since we're not starting with any product, the reaction is going to have to go to the right. So we'll call the change in Br2 minus x, the change in Cl2 we'll call minus x, and the change in BrCl we'll call plus 2x. So then at equilibrium, because we can add the initial and the change rows, we'll have 1.5 minus x for the Br2, 1.3 minus x for the Cl2, and 0 plus 2x will just be 2x for the BrCl. And now, I don't know the equilibrium concentrations, but I only have one unknown in that equilibrium row. And so I can write down the equilibrium constant expression. So we know that Kp is going to be the concentration of BrCl. Oops, let's fix that. BrCl. Well, actually, since we have pressures, not concentrations, let's use the correct notation. So we have the pressure of BrCl squared divided by the pressure of Br2 times the pressure of Cl2. Alright, so we can go ahead and plug in the expressions we have from the equilibrium row. So then this will become, and I'll go ahead and put in the value for Kp as well. So Kp is 0.010. Then we have 2x squared over 1.5 minus x times 1.3 minus x. Okay, so at this point, what I would do is go ahead and factor the denominator there. So let me rewrite things over here on the left. We've got a little bit more room. So we'll have our k. The numerator is easy. That's 4x squared. And then in the denominator, when I do the 1.5 times the 1.3, I get 1.95. And then 1.3 times minus x and 1.5 times minus x is going to give me minus 2.8x and then plus x squared. Alright, so now I want to go ahead and multiply both sides by that whole denominator to get all those x's out of the denominator. And so I'll have to multiply those by the left-hand side as well. And so we're going to end up with zero 0.0195 minus 0.028x plus 0.010x squared is equal to 4x squared. Alright, and now we need to subtract minus 4x squared from both sides. And so I'm going to rewrite it with the x squareds first. And so we're going to have minus 3.99 x squared minus 0.028x plus 0.0195 is equal to 0. Alright, so now at this point, we're left with nothing to do, but we need to solve a quadratic equation. So we need to use that x is equal to minus b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. Right, where the a, b, and c are the coefficients from our polynomial, where the a is a coefficient in front of a squared, b is a coefficient in front of x, and c is the coefficient in front of the x to the 0. Now, this is not a math class, and there are a lot of different ways that you can solve the quadratic equation. You can, of course, do it by hand, although nowadays most of your graphing calculators and scientific calculators can do this. Or if you have access to the internet through either a laptop, a tablet, or a smartphone, I recommend the website Wolfram Alpha. And this is made by the same folks that make the mathematical software Mathematica. So however you want to solve the quadratic equation, go ahead and do that, and I'll meet you on the next slide, and we'll talk about the results of solving that quadratic equation. Okay, if you had any trouble solving the quadratic equation, I'll make a second video where I work it out by hand. I'll also show you how you could use Wolfram Alpha to solve this. However you solve the quadratic equation, you should have gotten two solutions, which is not uncommon when solving a quadratic equation. But for these ice table problems, only one of the answers will make sense. The other one will either be impossible or it won't make any sense chemically. And so to see which of the answers we should throw out here, if the equilibrium partial pressure of BRCL is 2x, it wouldn't make any sense for x to be a negative number, because when I multiply that by 2, it'll still be negative, and so having a negative partial pressure doesn't make any sense. That's not possible. So that is the solution that we can throw out, and so then the only reasonable one will be x is equal to 0.066. So then to answer what the question is ultimately asking, they want to know the equilibrium partial pressure of BRCL, so I just need to take my x, multiply it by 2, and so we have 2 times 0.066, so that'll give us a partial pressure equal to 0.132 atmospheres. And that will be our final result.